Hello and welcome to my tutorial on static engineering systems. We're going to learn how to recognize different types of beams. And so what is a beam? Now, a beam is a structural engineering element capable of withstanding load primarily by resistant bending. And on the screen here I have a sketch of three types of beams that you might come across if you're studying civil engineering or mechanical engineering, especially if you're studying civil engineering. Now, beams are usually described by how they are supported. The supports, they basically act to restrict movements. It could be lateral movement or rotational movements. So these are the supports. I'll get another color just not to confuse you. So this would be the supports that I'm talking about. Okay, now the first one, this is called a simply supported beam, and it's basically a structural element supported by a pin at one end and a roller support at the other end. So this is a pin support, and this here would be a roller support. Forgot what I was going to say. Okay, now the next type of beam, this is called a cantilever beam. Now a cantilever beam basically has one fixed end. So one end of the beam is fixed to maybe a wall to restrict lateral and rotational movement. And the last type of beam that we're going to look at, I'll go back to red. The third one, which is the last one, is called a built-in beam. Now this is a beam where you have both ends of the beam rigidly fixed. So both ends of the beam is rigidly fixed to, I don't know, a wall or whatever, to maintain a horizontal slope. Is that how you spell maintain? Well, that would do. To maintain a horizontal slope. So you fix this end of the beam and that end of the beam to a structure to keep the beam horizontal. That's basically what all this means, this right here. Now bending is the most severe form of stress that you can apply on a structure. Think how easy it is to break something like a pencil, whatever, by bending it as opposed to stretching it or shearing it. So we're going to move on to describe the concept of point load. I'm going to move on to page 2 of a point load. Point load and a uniform load. So a point load is basically a single arrow acting on a point, and that would be a beam. And here, this is a point load. Whereas uniform loads is a series of arrows pointing downwards. So a uniform load can be shown as a series of arrows pointing downwards and has a value. So this has a value W Newton per meter. And by the way, this here is your distance. X is the length of the bar. You should have it here as well. For the uniform load, for any given length, X meters, total load is Wx Newton, don't forget your unit, and this is assumed to act at the center of the length, assumed to act at the center of that length. Essentially, what this here in the box, what all this is saying is you can convert that, or the uniform load, into an equivalent point load that would act at the center of the length. So you can so this would be the center, and that would be Wx newtons. Now, if that doesn't make sense, I recommend you you do further study on this, or Google it, whatever. But you need to understand this concept. The uniform load can be converted into an equivalent point load acting at the center of the beam.